In this video, I'm going to be going through the solutions for question 2 of the IEB Core Mathematics Paper 1 from 2021. Okay, so let's start with question A then. So it asks us to use first principles to find the first derivative of this function. So using the power rule, we can see what we are working towards, what we are eventually trying to find, and simply applying that to this function, we know that f prime of x should then be equal to 2x minus 5. And I got that by decreasing this exponent by 1, and of course multiplying by the original exponent for this term. And for this negative 5 term over here, what we did was we multiplied the coefficient negative 5 by the exponent of x, which is indeed 1, and so that remains as negative 5, and then we decrease this exponent by 1, and so then we have x to the power of 0 in the exponent, and anything to the power of 0 is just 1, so we're simply left with negative 5. So then the first derivative of f of x is 2x minus 5. But now we need to find this using first principles. So I just did this so that we know what we're working towards. Okay, so first of all, what's the formula? Well, f prime of x is equal to the limit as h tends to 0 of f of x plus h minus f of x all over h. Okay, so what is f of x plus h? Well, it's simply f of x where we are substituting in now x plus h every time we see an x. So f of x plus h is equal to x plus h all squared minus 5 into x plus h. Okay, so what does that expand to? Well, x plus h squared becomes x squared plus 2xh plus h squared. And if we distribute the negative 5 into this right-hand term, we get minus 5x and minus 5h. Now, simplifying this, okay, so we can't simplify it any further. So what we can do then is substitute this in for f of x plus h. So let's go ahead and do that. So, of course, we keep the limit as h tends to 0. And then for f of x plus h, we substitute this. So we have x squared plus 2xh plus h squared minus 5x minus 5h. And then from this term, which is our f of x plus h term, we are going to subtract f of x, which is x squared minus 5x. And this is all going to be over h. All right, now if we distribute this negative into this bracket, then we get negative x squared plus 5x. And the thing that you'll note now is this x squared and this negative x squared will cancel each other out, and this 5x and that negative 5x cancel out. Now what we're left with is the limit as h tends to 0 of 2xh plus h squared minus 5h all over h. But there's something interesting here. We can factorize out an h in this numerator. And so if we do that, we get the limit as h tends to 0 of h into 2x plus h minus 5 all over h. And you can see that numerator makes sense because now if you distribute this h back, you get this 2xh, and distribute it here, you get this h squared, and distribute it to the last term, negative 5, you get negative 5h. Okay, now what you notice is those two h's can cancel. So this simply leaves us with the limit then as h still obviously tends to 0 of 2x minus 5 plus h. But if h tends to 0, then this is just equal to 2x minus 5 plus 0, and of course we can just leave that out, and we have 2x minus 5. So using first principles, we've come to the exact same answer as if we were to just use the power rule, but because the question specifically said use first principles, that's what we've gone ahead and done. Okay, so let's look at question B now. So question B asks us to find the first derivative of this function g of x. Now, don't go ahead and use first principles here because it hasn't specifically asked you to, and that is going to be immensely difficult. So how should you go about this? Well, it's best to rewrite this in a form that is easy to differentiate using the power rule. So let's go ahead and do that. G of x is equal to, now for this first term over here, we know that x, the cube root of x, is equal to x to the power of 1 over 3, and that simply follows from the rule that if we have some number y to the nth root, then that is simply equal to y to the power of 1 over n. And that's just simply something that you should know, something that you should learn, because it makes this differentiation a whole lot easier. Okay, so g of x then, rewriting this first term, we write it as x to the power of 1 over 3. Now this second term, in order to bring this x into the numerator, which makes it easier to differentiate, we can simply make the exponent negative. So we have 6, of course this is still going to be plus 6x to the negative 1. Okay, now we have this in a form that's much easier to differentiate using the power rule. Okay, so g prime of x is going to be equal to 1 over 3, which is this exponent, times by x to the power of 1 over 3 minus 1, plus minus 1, which is the exponent, times by 6, which is the coefficient, times by x to the minus 1, and then minus 1 again. Okay, so that's just simply the power rule, and you should know this, so I'll write it generally for you. If we have some number y to the power of n, then its derivative is going to be n times by y to the power of n minus 1. And you can see that I've done that for both of these terms. Okay, so what we can do now is we can rewrite this in a way that doesn't look so complicated. We can just simplify it. So this term here is simply 1 over 3x, and now 1 over 3 minus 1, you can just type that in your calculator if you're really unsure, but it should be relatively easy. It's just 1 over 3 minus 3 over 3, and then you put that under the same base, and you have 1 minus 3 all over 3, and that is then minus 2 over 3. Okay, and for this term, we have negative 6x, and now minus 1 is minus 2. And that is this question B solved. And now, I know a lot of people want to now convert this back into something that looks more similar to this, but it's really not necessary. And in fact, I don't recommend it, because if you go now and convert this incorrectly into a form like this, then obviously you're going to end up with the incorrect answer. So it's just not worth the risk, and it takes up extra time. Okay, so let's move on to question C. So question C says, if h of x is equal to negative x plus p is a tangent to the function f of x equal to negative x squared plus 3x plus 4, then find the value of p. Okay, so the first thing to note is that if h of x is a tangent to this function, then the gradient of h of x and the gradient of f of x at the tangency point will be the same, because that's essentially what a tangent is. So let's draw this graph out roughly so that you can get an idea. So negative x squared plus 3x plus 4, I know that it will look something like that. And let me actually get rid of my axes, because I don't know exactly where it's going to intercept with my x and y axis, and it's really not important for this question. But I know it's going to look something like that. That's what f of x is going to look like. And I have h of x, which has a negative gradient, and it's going to be tangent to this graph. Okay, so if I move this line so that it's tangent, where can I make it so that it just touches once and doesn't intersect it? It just touches it. Well, the point of tangency is going to be over here. But now we have to find the value of p such that h of x is a tangent to f of x. Okay, well, like I said, one thing we do know is that the gradient at this point is the same for h of x and f of x. Okay, well, the gradient of h is constant because it's a straight line, and the gradient is the coefficient of x. So the gradient of h of x is going to be equal to minus 1. And you can obviously get that again just by doing the first derivative of h of x. Both of those ways of thinking about it are perfectly valid. Now, the first derivative of f of x is equal to, now once again I recommend you use the power rule. This is negative 2x plus 3. And now what we have to do is we have to equate these two first derivatives, which is basically equating the gradient functions. So we need to set h prime of x equal to f prime of x. So that then gives us negative 1 is equal to negative 2x plus 3. Okay, now if we take this 3 across, we get minus 4 is equal to negative 2x. Now dividing through by negative 2, we get x is equal to 2. So we know the x value of this point. It's going to be, wherever this intercepts the x-axis, is going to be x is equal to 2. That's this line here. Okay, but we also need this y value. So in order to get the y value, we can simply substitute in this x value into either the f of x graph or the h of x graph, and it'll give us this output, this y value output. Okay, so obviously we can't substitute it into h of x because we don't know p, so it's not going to give us anything useful, but we can, of course, substitute it into f of x. So f of 2 is then going to be equal to negative 2 squared. So this is, now remember here, to write it like that, this is crucial as opposed to negative 2 all squared, because this will be equal to 4, whereas this is equal to negative 4. Okay, so that's just a little thing to note to avoid making silly mistakes. And then that's plus 3 times by 2 and plus 4. And if we expand this all out, we get minus 4 plus 6 plus 4. Those 4's cancel out, and we simply get 6. So this point over here has coordinates 2 and 6. Okay, so if we have coordinates 2 and 6, then we can now work out p, because 2 and 6 also lies on the function h of x. So h of 2, we know, must be equal to 6. Okay, well, what we can then say, this implies that 6 must then equal to negative 2 plus p, and that's simply by substituting in 6 for h of x on this left-hand side, and substituting in 2 for x on this right-hand side. Now we can solve for p, and this means that p is equal to 8. So I hope you found this video useful and interesting, and if you did, please don't forget to leave it a like and subscribe to my channel. I'm going to be posting question 3 of this same paper very soon, so please stick around for that. Thank you.